Okay, car of mass 1.5 tons travels with a resultant force of 3,000 newtons. Determine the acceleration of the car. So sort of model this here in a force diagram. And notice it says here the resultant force. Okay, of course when you think about the movement of a car, what propels it forward is the engine, isn't it? It's the engine that's working that produces that driving force. Okay, but we know when we travel, okay, whether it's we walking or we're on a bike or we're in a car, we often have resistances, don't we? Resistant forces like air resistance, okay, and wind resistance and so forth, okay. So there are resistances for motion of a car, okay. We have to take that into account. But if you look at this question carefully, it already has taken this into account because here it's saying the resultant force. So that is what the forward force is going to be, okay, or that is what the overall force is going to be, okay, 3,000 newtons. So that takes into account the driving force of the engine and also the taking away the resistances such as air resistance. That is the overall sort of resultant there. So that makes it easy for us. And of course, when we use Newton's second law, we know resultant force equals to mass times acceleration. Well, the resultant force is 3,000. The mass, 1.5 tons, yeah? No, a ton is 1,000 kilograms, okay? Right, metric ton is 1,000 kilograms. So we need to sort of remember that. And then, so 1.5 will be 1,500 kilograms, yeah? Okay, so the mass will be 1,500 and then A. And of course, then to get A, you just take that over and divide. And you get A to be 2 meters per second squared.